What's up, everyone? So we're going to go through some different forms of equations of lines. So first and foremost, just being aware that instead of using the word slope, IB uses the word gradient. They mean the same thing, but it's just they choose to use the word gradient instead. So remembering that all vertical lines have a gradient that is undefined, and they have an equation of the form x equals a, where a is a constant. Remember, vertical lines, because they cut through the x-axis, that's why it's x equals a number. Versus horizontal lines have a gradient of 0, and they have the equation of the form y equals b because it's cutting through the y-axis. So that's why it's always y equals the value. All right, so first up is gradient-intercept form, also known as, or previously known as, slope-intercept form. It's called that because you have your slope, which is m, and your y-intercept, which is c. A lot of times in other non-IB classes, we'll use b instead. So if you write b, it's fine. They choose to use c instead. Point gradient form, also known as point slope form, is called that because you have m, which is still your gradient, and you have a point x sub 1 and y sub 1. That can be any point on the line. It's just some point that is on the line. And make note that you can also get the gradient formula out of this form. If you were to divide both sides by the x minus x1, you can have your gradient formula there as well. And finally, general or standard form looks a little bit different, and it's not quite as familiar than other forms, or as the other forms. So A, B, and D are integers. Remember, that means that they're positive or negative, but they're whole numbers, which is the key. If you have any fractions or decimals, it's not your final answer yet. Those three values, your coefficient of x, your coefficient of y, and then the constant at the end, they have to be integers. Sometimes standard form will have it equal to 0. Other times you might see D on this side. Usually in IB problems, they'll tell you how they want it if you look in the problem. All right, so just in case you haven't looked at it yet, I did post the formula booklet in Google Classroom. You would have access to this for any and all assessments. So if you haven't started looking at it yet, it's very long. It has a lot of information in it that we haven't talked about yet. But since we're talking about lines and they have the equations of lines in there, they do give you all three of those equations and the gradient formula. So you don't have to memorize any of this. It's just recognizing which type is which, because they don't explain which type it is here. They just give you the formulas. All right, so let's get into a few examples. All right, so our first example, we are finding in gradient-intercept form the equation of a line with a gradient of 2, and it passes through the point 4, 1. So two key things that jump out at me is I have a gradient of 2, and it tells me it passes through the point 4, 1. So just to remind myself what gradient intercept form is, it's y equals mx plus c. So that means already I know that I have my m because I have the gradient of 2. And the question is, what's going to be that c value? So how I'm going to find c is I'm going to take that 0.41 and sub in 4 for x and sub in 1 for y. And that way I can use that to find c. C is the only variable left in that equation. So I'll multiply 2 and 4 to get 8, subtract 8 from both sides, and I get c is -7. So just taking that y equals 2x plus c and rewriting it, my final answer would be 2x minus 7 equals 2x minus 7. All right, our next example, we are finding in point gradient form the equation of the line which passes through the point A, -1, 5, and B, 2, 3. So point gradient form, I'm remembering, looks like this. Okay, so this tells me I need the slope or the gradient, and I also need 1 point on that line to sub in for the x1 and the y1. So first, I'm going to have to find my gradient. So I'm going to say step 1. Either looking at the either looking at the formula booklet, remembering the gradient form or formula, or just dividing both sides by the x minus x1. I remember that my gradient formula is y2, technically, minus y1 divided by x2 minus x1. So using the points that I have here, the order of the x's and y's don't matter, just as long as you have, so if you notice like these two both have a 2, so they have to come from the same point. And the ones that have a 1 has to come from the same point. So it doesn't have to be 3 minus 5 divided by 2 minus negative 1. You could flip-flop it and it's fine. You just have to make sure the numbers that are stacked on top of each other came from the same point. I'm going to keep it to what I just said. So 3 minus 5 divided by the 2 minus negative 1. So I get negative 2 divided by, remember, adding the opposite, 3. So I just get negative 2 over 3. So the nice thing about point gradient form is now that I have my gradient, all I have to do is sub that in for m, pick one of the 2 points and sub in the x and y value from that point. That's it. There's no distributing, there's no simplifying. It's just a matter of deciding which point you want to use. I tend to always use the first point just because it's first, but you wouldn't be wrong if you use the 2, 3. It really doesn't matter which one you use. So I'm going to say y minus 5 equals my gradient times x minus negative 1. So I'm going to right away turn that into a plus 1. And that could be my answer. Or like I said, you could use the other point as well. So either one doesn't matter. Both are considered correct. All right, in our final example, finding in general form the equation of the line with gradient 3 over 4, and it passes through the point 5, negative 2. So remembering what general form looks like is we have ax plus by plus b equals 0. And remembering that a, b, and d all have to be integers. They have to be whole positive or negative numbers. So the issue is with the other two forms, I could just sub in a gradient and be good to go. If you notice here, there's no m, so I can't just sub in 3/4 and be ready to go. There's also no x sub 1 or y sub 1 to sub in my 5 and negative 2. So what I usually do for this is I'll usually start in point gradient form because I have a point and I have the gradient. And then I'll just manipulate the equation to match it to general form. So even though this is the form I'm going for, little arrow, so I remember that's what I'm going for. So to start in point gradient form, I remember that point gradient form looks like this. And because I have a gradient and I have my point, so I'm just going to plop those in. My y value is that negative 2, so y minus negative 2 means I'll add the opposite. My gradient is 3 over 4, and my x value is 5. So now all we have to do is maybe distribute some stuff. I'm going to have to deal with this fraction here, and then get everything onto one side. So I'm going to first distribute. I went like that because you don't have to. You could get rid of the fraction first if you would rather. When I distribute, I know a lot of us are a little apprehensive towards fractions, but I'm actually going to leave it as a fraction because it's going to make my next step easier. If you choose to use a decimal, it's not wrong, again, but it's just going to make it a little harder in our next step. So you could either do 3/4 times 5 in your calculator if you want to. I can also remember that 5 is over an invisible 1, which means I just multiply my numerators and my denominators. So now again, the major issue is I need integers and I need everything onto one side. So I'm going to deal with my integers first. Quick and easy way to get rid of your denominators, especially because they're the same number, is whatever that denominator is, I'm going to multiply both sides and everything on both sides by that denominator. If they weren't the same value, let's say this 4 was like a 3 or something instead, you would just have to find a common multiple between them and multiply both sides by them, by whatever that value is. If you're not sure what the common multiple is, you can multiply everything by one denominator and then multiply everything again by the second denominator. It's a little more work, but it'll still get you there. So that's all that matters. So I need to multiply again all terms by these 4s. So I'm just going to put in my distributing arrows. So on my left-hand side, I would have 4y plus 8. Right-hand side, remember the point of the 4 was that it would cancel out with the 4s that we currently have in the denominators. So both of these 4s just cancel right out with that one. There's no math necessary there. At least not algebraic math necessary there. You just can get rid of your denominators to have 3x minus 15. All right, so finally, I just want to bring everything over to one side. It doesn't matter which side you bring things to. I tend to always bring things to the left-hand side, but either way works. So if I'm going to bring everything to the left-hand side, I would subtract 3x from both sides and add 15 to both sides. So that I would have negative 3x, putting it in the same order as we have up here, plus 4y plus 23 equals 0 as my final answer. If you chose to bring everything onto the other side, then you would have the same numbers, but all of your signs should be flipped. So if you chose to bring everything over to the right-hand side, your answer would look like this. And again, also correct. So either way you feel comfortable writing your answer, we're good to go.